Hello viewers, welcome to this particular lecture on microelements. Now microelements, as it is called, they are required in trace amount or little amount for the development and metabolism of plant body. And these microelements mostly are obtained from the soil either in cation or anionic form, and they are taken up by the plant root. These microelements only in case of carnivorous or parasitic plants are obtained from other organisms which may include insects or which may include plants. As for example, carnivorous plants like Nepenthes or other carnivorous plant, they get their nitrogen supply from the insect, and along with that they also get some trace elements from their body. But that doesn't mean they cannot carry out photosynthesis. They do carry out photosynthesis and prepare sugar from photosynthesis. Similarly, for Cuscuta or Dodder, they are getting their supply of microelements from other host plant with the help of unique sucking roots or hostoria. Microelements can be enlisted as iron, manganese, boron, molybdenum, copper, zinc, chlorine, nickel, cobalt, sodium, silicon, etc. That means there may be metals and non-metals and even some gases which are considered as microelements. And as I told you, the microelements are required in trace amount, but if they are absent, then there will be some specific symptom. Now let us discuss about some of these microelements, their source, their function, and some of their deficiency symptoms. Iron, as you know, is a major element for microbes, but it is a microelement for plant. And in plant, they are mostly utilized for the production of heme protein or FES protein, and they are absorbed in the form of water-soluble salts. Iron can be used in the production of chlorophyll, it can be used as oxygen carrier, it can be used in nucleic acid metabolism, protein synthesis, or they can be used as a catalyst in different metabolic purposes, and even they are also required for nitrogen fixation. If there is iron deficiency, the most eminent symptom that comes up is the chlorosis. In fact, a particular leaf totally become yellow, only the veins become green. So that means iron, though it is not a constituent of chlorophyll, but is very much required for chlorophyll biosynthesis. Molybdenum is absorbed mostly from the soil in the form of molybdic acid or molybdate salt. It is an important constituent of nitrogenase enzyme which helps in nitrogen fixation. It is also useful for the production or function of nitrate reductase enzyme, which is very important for conversion of nitrate to nitrite. Similarly, it is also involved in protein synthesis, sulfur metabolism. It is also important for pollen formation or the formation of the sporopollenin or the pollen wall. Similarly, it is useful for iron absorption and translocation in the plant body. Molybdenum deficiency also shows browning of the leaf and chlorosis, but it starts from the margin of the lamina and gradually move inwards. Now boron compounds, they are mostly absorbed from borax, which is added to the soil, gets solubilized in water, and they produce borate. So this borate is absorbed from the soil as an organic matter, and it comes to the plant and it is actually utilized within the plant cell. Boron fertilizer is more soluble in acidic condition. So what does it mean? It means if the soil is acidic, that is the pH is below 7, boron availability increases for the plant. And if the soil is gradually becoming alkaline, then boron availability reduces and there will be definite symptoms of boron deficiency. But definitely under high rainfall condition, again there will be carbon dioxide which is solubilized in water, and thus pH again become acidic and boron availability increases. Now actually the boron which is absorbed by the soil is taken up by the cortical cells. Gradually it is going up through the xylem vessel, reaches the leaf where it is utilized and stored. And in the same way, boron is also useful as a cofactor in the activation of different enzymes. Now the boron functions may include flower production, production of anther, production of pollen tube. In the same way, it is helping in seed setting, in sugar transport, plant productivity, and also in the cell wall, phloem translocation, nodulation, nitrogen fixation. And there is also some role of boron in potassium utilization, chlorophyll production, phenolic content, plant respiration. So that really means boron is a multidimensional element, though in less amount it is required for different purposes in the plant body. And there may be specific symptoms which actually is considered as deficiency symptoms, which include the withering of the shoot tip or the root tip or the stem tip, and the shoot tip or the growth of the stem is reduced. There will be necrotic spots, their leaves will be thickening and they will be gradually becoming brittle, there will be rust colored symptoms, and the root tips often actually shows withering. And at the same time there may be specific boron excess symptoms. This actually means if boron is applied in excess in the form of boric acid or borate, then the leaf tips become yellow and they appear as burnt leaves. And sometimes these burnt yellow leaves also dry and they fall off. So early falling of leaves definitely will indicate reduction in photosynthetic activity. Copper is useful for the production of carbohydrate and nitrogen metabolism. It is also used in the production of electron carrier in the electron transport system, utilization of iron, and definitely it is ensuring fertility to male flower. And there will be definite disease resistance mechanism associated with copper uptake. Deficiency will show some specific symptoms. That is, the younger leaves, there will be interveinal chlorosis, and the tip of the leaves, they remain green, but gradually the chlorosis becomes all over the leaf, and there will be extensive necrosis on the lamina. In the same way, deficiency can also cause specific symptom in specific plant, and that include the dieback disease of the citrus plant or the reclamation disease of rice plant. Here also there will be some excess symptom, that is, if there is excess of copper, there will be copper toxicity in the plant, and that will include interveinal chlorosis, that will include less availability of iron, there will be few branches that will be growing, there will be decaying of root and overall reduction in growth. So that means copper in excess is not good for the plant. Now manganese as such is also obtained from the soil as a cation and solubilized within the plant tissue. Manganese is necessary for photosynthesis, nitrogen metabolism, it is producing a different host of compounds, and it is also useful for activation of some enzymes which include the superoxide dismutase. And this enzyme is actually an anti-aging enzyme which will make the plant look younger for a longer period. So as we see, manganese is definitely useful as a cofactor for the activation of different enzymes. And there will be definite deficiency symptoms which include interveinal chlorosis like that of copper, and there will be mostly on young leaves, and at a later stage these leaves will turn grey or brown and will drop. So this chlorotic lesion is a very common problem with manganese deficiency. And if it is observed that the manganese uptake is low, then there will be deficiency symptom, and this limit is below 25 ppm. So manganese requirement below 25 ppm is not fulfilling the plant growth, and there will be stunted growth. And in the same way, like other elements, excess of manganese also can cause problem. Like if it is excess manganese, then the shoot will show definite chlorotic or dark orange spot, and there will be brown mottling or hardening of the leaves, and the leaves become brittle. There will be tissue damage located in the young leaves particularly, and not that much in older leaves. Now, sodium actually is an essential element, but it is mainly absorbed by the plant along with chloride. So, it is a common salt which is absorbed in solubilized form. And sodium as such is having the same specific symptoms like potassium deficiency. And sodium uptake actually is brought about by specific receptor. And these receptors will include the SOS or SOS1, which is in aggregation with H plus ion intake. So, there are SOS1 receptor which on one hand is absorbing sodium ion, and in the opposite way they are giving out hydrogen ion or H plus ion or proton. So, thereby we can say it is a unique antipode mechanism involving the cationic channel where the sodium ion is taken in and proton is given out. In the same way, there is the ATNHX1 which is actually having the proton given out and sodium ion absorbed. But here it is not within the cell but from the cell into the vacuole. So, what does it mean? It means that sodium is not only taken up by the cell cytosol, it is also taken up by the vacuole or vacuolar sap, and it is stored within the vacuolar sap. As I already told you that the sodium ion deficiency is same as that of potassium ion, showing chlorosis. Zinc is an essential component of three different enzymes, and these enzymes are carbonic anhydrase, alcohol dehydrogenase, superoxide dismutase. Zinc is very important for the production of indole acetic acid, which is a most important growth hormone or auxin for the plant, and deficiency of zinc will cause improper activity of indole acetic acid and there will be low plant growth. In the same way, zinc is also useful for water uptake and they play an useful role in stabilization of protein. Zinc is also important in the form that zinc will actually remove or reduce toxicity of some other heavy metals like cadmium. And if the zinc content of the plant is less than 15 ppm, there will be deficiency symptoms. And these deficiency symptoms will be primarily in the form of chlorosis observed in younger leaves, and the leaves become brittle, and sometimes they are mostly seen in calcareous soil. Zinc also, like other element, if given in excess, will show some excess symptom, like there will be severe toxicity and death of the leaves if zinc is given in excess, or in sometimes there will be iron deficiency because of excess zinc. So, the iron deficiency symptoms will be pronounced if zinc absorption is more in a plant body. Nickel actually is a heavy metal, and in no way nickel should be considered as a useful element. But sometimes nickel is useful for some purposes, and that include urea metabolism, and also it is useful for the growth of the root of legume crops. And nickel as such in +2 form is mobile within the plant, and the deficiency symptoms definitely will show some necrosis on the margin, and this is often termed as mouse ear symptoms. So, nickel deficiency has some specific symptom, though at the same time we can say nickel is not required in bulk amount and it may be toxic for the plant. We come to the next element, which can be a gas, which is chlorine, but actually in plant it is absorbed as an anion, which is chloride ion. And this chloride ion, as I told you, is often taken up in the form of water soluble salts like sodium chloride, and once it is going in, it is required in different purpose, which include the ionic balance That is the maintenance of cation and anion on both sides of the membrane, which is called electrical equilibrium. In the same way, the chloride ion is also useful for carrying out photosynthesis process. There are different deficiency symptoms of chloride, which include abnormal shape of the leaf or the lamina, and there will be intervenal chlorosis. In fact, we see that many of these elements which are microelements, they show intervenal chlorosis. So apparently by seeing a leaf, it is very difficult to conclude that which particular metal or which particular microelement is deficient. Next we come to cobalt. Cobalt is a heavy metal, but at the same time cobalt is useful as a microelement. It is required for the formation of vitamin B12 or cyanocobalamin. This particular vitamin is not required in bulk amount for the plant body, but they really are involved in the growth and development of animals and some lower plants. But cobalt is mostly useful for nitrogen fixation, for the development of the nodule, for the colonization of the rhizobium bacteria in the leguminous plant root. And therefore we say that the activity of the nitrogenase is also somewhat dependent on cobalt. In fact, cobalt and molybdenum, they are very important along with iron for nitrogen fixation. So if there is cobalt deficiency, definitely there will be low number of nodules and the legume plant will be deficient in protein. Rather, we say that the nodule bacterial association will be reduced if there is cobalt deficiency in the plant. We come to the next important element, which is aluminium, which is a light metal. But aluminium has got different types of role, which include the toxic effect, which include the beneficial effect, which include the tolerance, and of course exclusion. In every way, aluminium is important. It is beneficial in the sense it is stimulating plant growth, it is promoting nutrient uptake, it is helping in defense against pathogen, and at the same time it is also increasing the metabolic activity along with antioxidant activity. And definitely aluminium concentration is useful for the change in flower petal coloration. But aluminium in excess can actually cause some toxic effect, and that will include inhibition of root growth, and it will block water and nutrient uptake. There will be more lipid destruction in the form of lipid peroxidation, and also there might be some inhibition of cell division. But aluminium normally is tolerated because it is chelated, it is useful for the aluminium transporter activation, it is modifying the plant metabolism, and sometimes it is also acting as DNA checkpoints during cell division. And excess of aluminium sometimes can be given out along with plant exudate. So it is very interesting, if there is change in pH, if there is change in the plasma membrane constituent, the aluminium might be given out by the plant. So in one way, the plant will produce some mucilage which contains aluminium. So that means the plant are really selective. They only take up that much of aluminium which they require, and if they have absorbed accidentally more aluminium, that is given out with the exudate. And the deficiency will definitely show some chlorotic lesion coming from the margin of the lamina. We come to the next important element, which is the silica. In fact, silica is so important that silica can actually replace carbon in different plant tissue. It has got some physiological purpose. It is giving resistance to pathogen. At the same time, it is allowing the utilization of potassium and phosphorus. It is alleviating salt stress, and also it is reducing other heavy metal toxicity. So it is really unique. At the same time, there are some grass leaves where the silica is present in the silica cells, and this silica will actually give them mechanical support and also will act as an anti-grazing compound. It is not normally grazed by the animal. Silica at the same time is absorbed by the soil, and silica from the soil get into the plant, and if there is some metal toxicity, because the soil is contaminated, silica will alleviate the metal toxicity. The silica deficiency definitely is ideally observed in the lamina, and this is mostly seen in the different coloration. It will start as yellow streaks, but gradually the streak becomes more brown or orange in color, and definitely it will spread entirely along the lamina, ideally observed in grass leaves. Now, vanadium as such is required in trace amount. We would say trace amount, that is so little that it cannot be measured. But as a matter of fact, if vanadium deficiency is there, there will be some unique symptoms like the curling of the lamina or the incomplete development of the buds. So, though we say vanadium is not a useful microelement, but the deficiency symptoms are very clear. Selenium sometimes is required by the plant as a heavy metal because it will regulate the reactive oxygen species, it will reduce other metal toxicity, and that include arsenic. Because West Bengal is having adequate arsenic in the groundwater, arsenic uptake is very common by plant, and the arsenic toxicity in plant can be reduced or checked by selenium content. In the same way, selenium is also useful for the growth, development, photosynthesis, maintenance of cell structure and function. So, these were the different microelements. I talked about the metals, non-metals, gases, etc. Now, let us discuss little bit about how these microelements are applied, and because they are required in trace amount, they have to be given along with NPK fertilizer. There are two main ways or major ways of applying these micronutrients to the soil, and that include granules which are added as soil additives or fertilizer additives, or the other one is foliar spray, where we are giving the micronutrients directly onto the leaves and they are directly taken up by the natural opening present in the leaf. Now, when we talk about fertilizer or granular form, there are four major ways of adding micronutrients. One is incorporation into the granular fertilizer. Second one is bulk blending with the granular fertilizer, and they are actually, we are giving the exact micronutrient dose so that they can be easily absorbed. The third one is coating onto the granular fertilizer, where we are using NPK fertilizer, but we are coating it with microelement so that they are required in less amount. And the last one, which is most popular, is mixing with the fluid fertilizer because they are water soluble, and in both way they can be used in the foliar leaves as well as in the root. Now, when we talk about foliar spray, they are really very important because foliar spray, that way they are cheaper, they are more effective because directly they can reach the plant tissue. But more the advantage, there are also some disadvantages. Let us talk about the advantages first. First of all, the application rate will be low because you can directly spray it onto the plant. You can apply it uniformly all over the plant. The nutrient requirement is immediately met so that immediately the deficiency symptoms can be met. So, these are the advantages. But the disadvantages include sometimes if there is excess of salt, there will be leaf burn or burn-like symptoms or salt toxicity. And sometimes the nutrient demand often is so high and the plants are small, the leaf surface is insufficient to meet the actual requirement of that particular microelement, so there will be deficiency symptom. Thirdly, the maximum yield may not be possible because ultimately more absorption occurs to the root, and in the foliar spray the nutrients are not reaching the roots. Next, there will be some residual toxicity because it remains on the leaf surface. And sometimes we are actually mixing it with some additives and that increases the cost. So, though it is more effective at times, but it is not always suitable for bulk production or low cost production. So, thereby we can say that microelements are very useful constituents that the plant require for their growth and development. These microelements can be metals, non-metals or gases, but these microelements are mostly obtained from soil, and each of these microelements are complementing each other. Sometimes they are functional together, helping in the plant growth and metabolism, and sometimes they are reducing the toxicity of other heavy metals. And lastly, I have talked about the different ways these microelements are added to the soil, which included the direct granules added as soil dresser with the biofertilizer or with the chemical fertilizer, or directly given as liquid onto the foliar leaves or onto the foliage in the form of foliar spray. So this is all about microelements. Thank you.